curve C has the equation y equals x over 9 plus x squared. Use calculus to find the coordinates of the turning points. So I know the turning points are where the gradient equals 0. So I need to differentiate this function to get my gradient function, and then I need to make it equal 0. Now to differentiate this, I can see that we've got a fraction, we've got a quotient, we've got x on the top, and we've got 9 plus x squared on the bottom. So I need to use the quotient rule for this. So I'll let my u equals x, and I'll let my v equals 9 plus x squared. We will differentiate this. So we'll differentiate the u first. So differentiating x, I get 1. Now differentiating v, differentiating the 9, I get 0, and differentiating the x squared, I get 2x. Now let's remember that the quotient rule, and we do get given this in the formula booklet, is u dash v minus v dash u all over v squared. So in this case, we'll have 1 times 9 plus x squared, that's my u dash times v, minus my v dash times u, all divided by the v squared. Expanding those brackets and simplifying, so the 1 times 9 plus x squared is 9 plus x squared. Then we have minus 2x times x is minus 2x squared. And I'll leave the denominator as it is. The numerator simplifies a little bit more because we can collect up those like terms. The x squared minus the 2x squared is minus x squared. So this is my gradient function. I now need to find when does this equal 0 for the turning points. Well, the only thing I really need to focus on here is the numerator. If 9 minus x squared equals 0, then the whole thing will equal 0. As long as the numerator is equal to 0, then when I divide that by the denominator, it's going to equal 0 as well. So then we can solve this equation, and we can say that x squared is equal to 9. So x is going to equal either 3 or minus 3. We can now get the y coordinates by taking these values and substituting them back into the original expression. When I substitute 3 into that, I get 1/6. When I substitute minus 3, I get minus 1/6. So the coordinates of the turning points are 3, 1/6, or minus 3, and minus 1/6. That's part II. Those are my answers for part II. Part I, sorry. Now let's move to II. So given that y equals 1 plus e to the 2x, all to the power of 3 over 2, we need to find the value of dy by dx at x is equal to 1/2 ln 3. So we want to differentiate. To differentiate this, I'm going to use the chain rule because I've got the 1 plus e to the 2x inside the function where the power is 3 over 2. So let's differentiate the outside function first, so the power. So when I differentiate the power, I'm going to multiply by the 3 over 2. The inside stays exactly the same, and I'll take 1 away from the power. 3 over 2, take away 1, is 1/2. Now by the chain rule, I need to multiply this by the derivative of the inside function, the yellow function on the inside, which was 1 plus e to the 2x. When I differentiate the 1, I get 0. When I differentiate the exponential, I get the exponential, so I'll get e to the 2x, and then I need to use the chain rule again because of the 2 on the inside here. So I now need to multiply by 2 as well. Right, let's just simplify that a little bit here, because I can see that the timesing by 2 and the half here will cancel out. So I'll get 3e to the 2x times 1 plus e to the 2x to the half. That is my gradient function. And I need to find the value when x is 1/2 ln 3. So let's substitute that in instead of the x. So we'll get 3e to the 2 times 1/2 ln 3 multiplied by 1 plus e to the 2 times 1/2 ln 3 all to the power of 1/2. Now, I can see that the 2 times a half cancels these things out here, and the 2 times 1/2 cancels these things out here. I then get e to the ln, which cancels out and just gives me 3. So 3 times 3. Then on the inside here, again, the e to the ln here cancels out and just leaves me with a 3. So I'm just left with the 3 times 3, and on the inside of the brackets there, the 1 plus 3 is 4. 4 to the power of a half is 2. So 3 times 3 times 2 is 18. And that is my answer for part II.